Hello dear participants, once again I welcome you all on online value based course on chemical handling and laboratory safety CHLS 2022-23. Myself Dr H G Wankhade, Assistant Professor, Department of Chemistry, Shri Shivaji Science College, Amravati. Today we are going to discuss on the precaution to be taken while performing the titration. Now question arises, what is the titration? So it is a basic experimental determination method which we oftenly use in a chemistry laboratory to determine the concentration of unknown solution. So this we can call it as titration is a classical method of quantifying the amount of an unknown solution, and we can define titration as a quantitative and qualitative technique to determine the unknown concentration of a solution by the known concentration of solution in the presence of indicator is called as the titration. Now there are some terminologies associated with the titration, that is titrate, titrant, endpoint and the indicator. So titrate, titrant and the indicator are the basically components of the titration. So what is the titrate? Titrate is the solution of unknown concentration used in a titration whose concentration we are going to determine, that is called as the titrate. So titrate is always taken in a conical flask and whose concentration we are going to determine. Second one is the titrant. What is the titrant? Titrant is the solution of known concentration which is used to determine the concentration of unknown solution. So this titrant is always filled in a burette. Next one is the indicator. What is the indicator? Indicator is the substance which will tell us about the completion of the reaction. So at the completion of the reaction, the color change is observed, and that color change is due to the presence of indicator in a solution. And what is the endpoint? Endpoint is the point at which the color change is observed, which indicate the completion of the reaction. So this is all about the introduction of the titration. Now that there are the different types of the titration, basically 4 types: the acid-base titration, redox titration, precipitation titration and the complexometric titration. Let's discuss one by one. Very first is the acid-base titration. Now what is the acid-base titration? It is a titration where we are going to determine the concentration of unknown acid with the help of the base of known concentration, or vice versa. We can determine the concentration of the base by using the acid solution of the known concentration. So basically this is a neutralization reaction. So on the basis of the amount of acid required to neutralize the base or amount of the base required to neutralize the acid, we can determine the concentration of unknown acid or the base. We know that when acid react with the base will form a salt and the water. So when all the acid is neutralized by the base, the reaction is get completed, and that is our end point of the acid-base reaction. So we can define the acid-base titration as it is a quantitative analysis method to determine an acid's or the base's concentration by precisely neutralizing them with a standard solution of either acid or base of known concentration. It is monitored with the help of the pH indicator to know the development of acid-base reaction. Now the acid-base reaction is also further classified into 2 types, that is called as the acidimetry and the alkylimetry. So what is the acidimetry? In acidimetry, we are going to determine the strength of the acid by using the alkali solution of known concentration, or this is also called as the standard solution of the base. Second one is the alkylimetry. So in alkylimetry, we are going to determine the strength of the base with the help of the standard solution of the acid. The standard solution of acid means the solution of acid of known concentration. The example for the acid-base titration is titration of oxalic acid with the sodium hydroxide. So there are the many examples of the acid-base titration. So this is the one of the example, the titration of oxalic acid with sodium hydroxide. Next one is the redox titration. So as its name itself indicates, so this is the titration in which the reduction as well as the oxidation reaction takes place. So that's why this is called as the redox titration. So in this type of the titration, the chemical reaction takes place with the transfer of electron in the reacting ion of aqueous solution. There are the different types of the redox titration which are named after the reagent which are used in a titration, such as the permanganate titration, dichromate, and the iodometric or iodometric titration. So very first is the permanganate titration. In this titration, the potassium permanganate is used as an oxidizing agent. It is maintained with the use of dilute sulfuric acid. Why we are using the dilute sulfuric acid in a permanganate titration? Because we know that potassium permanganate is a strong oxidizing agent, but it can show its oxidizing properties in the presence of the acid. So that's why we are using the sulfuric acid. So when this sulfuric acid react with the KMnO4, it generates this oxygen, nascent oxygen, and this oxygen then used to oxidize the component or the oxidize the substance. Or on an electronic way, we can also say that when the KMnO4 react with the H2SO4, so where MnO4 minus means here in a KMnO4, the oxidation state of the Mn is +7 and it is get reduced to +2, means it reduces to the +2, means it will take the 5 electron. That's why it is taken that 5 electron from the other component, so it oxidizes the other component and itself get reduced. So and in KMnO4 we doesn't require any indicator because permanganate is a self indicator. Now in a permanganate titration, what will happen? The before the end point your solution is colorless. Then we are adding KMnO4 into the titrate में हम लोग KMnO4 को ऐड करेंगे and at the end point the color of the solution is changes to the pink. So that's why this is the self indicator. We need not use any external indicator to determine the end point in a permanganate titration. So the potassium permanganate is used to estimate the concentration of oxalic acid, ferrous salt, hydrogen peroxide, oxalates, and many more. So this is all about the permanganate titration. Next one is the iodometric or the iodometric titration. So here in this titration, in this redox titration, the reduction of either free iodine to the iodide ion or the oxidation of iodide ion to free iodine takes place. So when I2 is the free iodine, when gains the 2 electron from the iodide ion, so this is the reduction reaction. So this kind of the titration where the free iodine is used in a iodometric in a titration, that titration is called as the iodometric titration. Means in iodometric titration the reduction of the free iodine takes place to leads to the formation of iodide ion, whereas in iodometry the iodide ion is oxidized to free iodine. So this is the iodometric or iodometric titration. In this titration we need to use the external reagent and the external indicator, and mostly the external indicator used is the starch. Third redox titration is the dichromate titration. These are the titration in which the potassium dichromate is used as an oxidizing agent in acidic medium. Again, as like KMnO4, K2Cr2O7 is also the strong oxidizing agent, and this is also showing its oxidizing property in a acidic medium. That's why we always maintain a dilute acidic medium when we are carrying out the dichromate titration, because when K2Cr2O7 react with the H2SO4, they are produce this nascent oxygen, and this is used for the oxidation of the another component. Or even we can say that in K2Cr2O7 the oxidation state of the chromium is +6 and when it is react with the sulfuric acid, it is get converted to the plus 3, means it is get converted from plus 6 to plus 3 by the gain of 3 electrons. So if we gain the 3 electron, means itself get reduced, so definitely it will oxidize the another substances. The solution again, for the solution of the potassium dichromate, we need not need any external indicator. So because potassium dichromate itself act as an indicator. So this potassium dichromate is mainly used for the estimation of the ferrous salts and the iodides. Next type of the titration is the precipitation titration. So as its name itself indicates, the precipitation occurs into the titration. So this titration is based upon the formation of the insoluble precipitation when the two reacting substances are brought together in contact, and this kind of the titration is called as the precipitation titration. So example for the precipitation titration is when we react the silver nitrate with the ammonium thiocyanide, we will get the precipitate of the silver thiocyanide. Or you can also have the, when we react the silver nitrate with the sodium chloride, we will get the white precipitate of the silver chloride. So this is the titration where we will get the insoluble precipitate when the titrant is added into the titrate. Now next one is the complexometric, next and the last is complexometric titration. So again, as per its name, this is the titration where the complex is the formed during the course of the reaction. Means when we add the titrant into the titrant, so both the substances react to form a complex. So in complexometric titration is the where the undissociated complexes is formed at an equivalent point, and it is greater than the precipitation titration, and there will be no error due to the co-precipitation. Means in precipitation titration you will get the error because of the co-precipitation, but such a kind of the error is not observed in a complexometric titration because it is formed in a large extent and it is a undissociated complex. That's why there is no error is observed because of the co-precipitation. So mostly EDTA is a very important reagent which is used to form the complexes, is the complexes with metal, and they are used in a complexometric titration. So here you can see the mercury with the +2 charge when react with the thiocyanide, it is formed the complex mercurous thiocyanide, or when the silver react with the cyanide, is formed the silver cyanide complex. Now what are the components of the titration assembly? Means up till now we discussed about the definition of the titration, the component of the titration, the different types of the titration. Now what are the components of the titration assembly? Because when you are performing the titration in a laboratory, we require some glasswares. So that glasswares are to form the titration assembly, and these are the components which include your burette, pipette, volumetric flask, conical flask, funnel, beaker, and the polythene bottle. So very first component of the titration assembly is the volumetric flask. So what is the role of the volumetric flask in a titration? It is to prepare the solution of known concentration. So we earlier already discussed in a previous lecture how to prepare the solution. So let's once we have a revision on that. You have to take a volumetric flask and wash it with the deionized water. Then take a accurate amount of the weight of the solute and transfer that weight of solute into a beaker and dissolve that solute in a little amount of the deionized water. But before transferring the solute into beaker, keep in mind that beaker must be washed rinsed with the deionized, properly washed, and then later on rinse with the deionized water. Then after the dissolution of that small amount of the dissolution of the solute in small amount of deionized water, transfer that solution into volumetric flask and then fill the volumetric flask with the distilled water up to the mark. The last filling means with the help of the dropper to achieve the bottom meniscus of the mark. So keep in mind that for colorless solution you have to take the lower hemispheres of the solution and mark, and for the colored solution you have to consider the upper hemispheres. Then stopper the flask and invert that flask for the 20 times to ensure the mixture is homogeneous. So this is the role of volumetric flask in a titration to prepare the solution of known concentration. Second one is the pipette. Pipette is the second component of the titration assembly which is required to pipette out the desired amount of the titrate and to transfer that solution into the conical flask. So before using the pipette, first rinse that pipette with the deionized water and followed by the liquid which is you are going to use. Then use the pipette filler to draw the level of the liquid to above the mark. So this is the pipette filler. So you can use the rubber core or the certain pipette out devices. Then next, allow the liquid return to the waste beaker until the bottom of the meniscus is on the mark. For example, if you have to take the 3 ml of the solution, so with the help of this stopper, with the filler, you can suck the solution into that pipette. So for example, solution up to come to this mark and you required up to this mark, just put the remaining solution into that beaker and stop at this point. When you reach to this point, transfer this solution to your conical flask and keep in mind that allow the liquid to drawn under the gravity into the conical flask and do not blow the last drop out from the pipette. Okay, so this is the use of the pipette in a titration. Next one is the burette. So we know that burette is used to fill the titrant with the solution of your known concentration, which is used to determine the concentration of the solution of unknown concentration. So same thing you have to carry out over here. First you have to ionize the burette with the rinse the burette with the deionized water, then rinse with the some certain quantity of the solution, so that you must sure that the no water droplets are present into the burette, which will dilute your solution of known concentration. Then with the help of the small funnel, fill the burette. Although it will have the 0 mark over here, but you have to add certain extra amount of the solution in a burette to fill this lower part of the burette. So once you fill the burette, then fill that burette upmost top and then open this tap to fill the lower part of this tap, and make sure that there is no air bubble present in the below the tap. Then fill the burette up to until the bottom of the meniscus on the upper mass. Means you have to fill up to there, and again you have to see the for colorless solution lower hemispheres and for the colored solution the upper hemispheres. Then clamp this burette to the vertically to the stand, and always read the volume at the eye level and at the bottom of the meniscus. So don't see the level at above or the below. When you are notifying the reading, it should be at the eye level. Next component is the conical flask. Conical flask is used in a titration where we are add the titrate into the conical flask. So before using the conical flask, you have to wash it with the deionized water, and do not wash out with the solution it is to contain. It will be holding an exact volume of the solution, and so if it was washed prior to this with the solution, it will be have the droplets and which will affect the volume of our solution. So titration, this is all about the titration. So it is a laboratory procedure where the major volume of one solution is added to the known volume of another solution until the reaction is get complete. So how we are going to perform the titration to get the accurate reading. So as we already discussed that we have to how to use the component of the assembly, we need to rinse and wash it out properly. Fill the titrant into the burette and titrate into the conical flask, and add the titrant drop by drop till the end point is achieved. And after each addition, you have to shake the solution to observe the color change. Thank you. This is all about the titration.